How's my hair? How am I looking? It's been a little while, right? Okay. We've skipped over lines. I'm going to make videos on that later, but we're technically past that unit, so let's be in the now, yeah? Let's take a little moment to talk about absolute value. So I'm going to try my best to make this simple, but we're going to go through one long problem, and then we're going to kind of do it in the reverse, so you can stop and start if you need to. It might take about 15 minutes, that's my guess. So let's talk about what absolute value is, okay? And we're working our way toward absolute value. Absolute value graphs. Can you see that? You can see it. So let's throw something out there that we would consider like a line, right? Well, actually, no, let's start over. Let's start at the very beginning. It's a very good place to start. The basic idea of a linear function is y and x balanced to each other in the first degree. Okay? So that creates this linear thing which can shift, right? Or it can tilt, but it's what we call linear. Okay? Absolute values throws this guys on there. So before we do anything, we need to identify what makes up an absolute value, because lines are infinite in either direction, so you just need 2 points, you can figure it out. Absolute values move, and every subsequent function from now on will move, and curves and turns, and you need to look for the places where it turns, okay? You need to look for those up, down, so you have to figure out how to analyze the equation and how to analyze the graph to find those. Very first, before anything else, we're just going to plot points like you do in your very first beginning to learn how to draw a line, right? So let's start with this. X. Y equals absolute value of x. Oops, I need to do the other side. And finally, y. This is our table. Remember, these are our inputs and output. Fancy way of saying domain and range. Do you remember those words? I hope you do. I'm going to get another marker. So we can pick whatever we want for x, and you always can. The thing about graphs, and let me remind you here, is if you don't pick the right thing, if you don't pick the right area, you won't see the turning and you won't know what's going on. So that's why we use this to try to springboard into deeper analysis. So I'm going to pick anything, right? In my chocolate factory, what's going to punch out on the other end? And I'm going to make it broad though, because I know where this is headed. So we're going to say, how about -5, -2, 0, 2, and 5. If ever you're going to try to graph by a table, try to balance it to start, but you have to have the most elementary thing, right? So I picked this. Y is equal to the absolute value of that, so I just want the absolute value of that every time, and that's going to give me what I want. So the absolute value of -2, 0, 2, 5, that's my function. I put all these different things in the function. Oops, -5. What do I get out? Well, the absolute value of -5, absolute value turns whatever's inside of it positive, right? So absolute value of -5 is just 5. Absolute value of -2 is 2. We turned it positive. Absolute value of 0 is 0. The absolute value of 2 is 2. Finally, 5, 5. Okay? That's what this symbol means. Absolute value means whatever's inside turns positive. Just what it is. Well, how does that reflect in a graph? Okay, I'm going to do a graph right over here. I'm going to slide this over. Ready? It's really fancy. It's fancy. I turned the tripod. It's high tech. Here's more fancy. me sketching this out. I am declaring two directions. In math class, we're almost always declaring two directions because we are trying to figure out what is happening. What's happening? Because that ultimately, you can get up to big graphs that show how all sorts of things move and are shaped, and it's fascinating. We have to start small. We have to start somewhere, right? So let's plot these points. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Super methodical. Alright, are we in here? Are we in the frame? Are we doing it? Are we doing the roller? There we are. There it is. Good times. Alright, so -5, +5. 1, 2. Remember, these are the positive directions, like our north and our east. These are our negative directions, our west and our south. 1, 2, 3, 4, 5. And we go up 5 for the y. So this is the x, and then 1, 3, 4, 5, y. Point. Negative, I'm starting here every time, right? This is our, we remember, it's called the origin. Origin. This is our starting point. 1, 2, 1, 2. 0, 0. At the origin. We're going to find this a fancy term later. 2, 2, and 1, 2, 3, 4, 5, and 5. Alright, are we there? Now, we get to connect the dots. Would you agree that even if I put in -1/2, that would become +1/2? So I could say there. And if I put in -1/4, it would become +1/4 and it'd be there. And what about +1/2 would become +1/2, and all the things in between. So actually, when we fill in all the infinite values that we could plug into this, we do get this kind of a shape. I suppose I could get out a ruler, but so this, every absolute value looks like a V. Okay? And in that V, this is called the vertex. It's like the place where it turns. Now, any further discussion on these graphs is going to be us analyzing the vertex. How can you find it just from this? Okay? So I'm going to do high tech, spin this camera over there. We're going to do the problem in the corner. Ready? Are you ready for it? It's really fancy. Watch. Oh, there we are. Now we're in the corner. Oh, man. Oh my gosh, Miss Thompson, that was so high tech. Okay. Let's throw this down. I'm going to do this. Are you ready? Are you going to pick up what I'm throwing down? I'm about to. I'm going to call this example. 2. What if I said this? Y equals absolute value of x minus 3. Oh, let's do absolute value of x minus 3 like that. I'll do that one. Well, if I have my table, if I picked all these same values, right? -5, -2, 0, 2, 5. I can see that I know the absolute value of x because I found it all out over here. So I can take all those values and subtract 3 from them. Absolute value of -5 is 5, minus 3 is 2, right? Absolute value of -2 is 2, minus 3 is -1. Absolute value of 0 is 0, minus 3 is -3. Absolute value of 2 is 2, minus 3 is -1. And absolute value of 5 is 5, minus 3 is 2. So now I have these points, and I'm going to do this a little tinier. And I'll have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I went -5 and +2, -2 and -1, 0 and -3, 2 and -1, 5 and 2. We still have this V shape. But now you may notice the entire thing dropped. Well, how far did it drop? What is the point of this vertex? Here's our vertex. The vertex is the place where it turns, right? So there's our vertex. And what are the coordinates of this vertex? I didn't move in the x direction, but I dropped 3 in the y. So my vertex is 0, 3. Well, how did that change that, right? I can look and I go, -3. Wait, I went down 3. My vertex moves down 3. Whatever's outside of this moves it down, okay? All right, we're only about halfway through, but I'm going to pause here, clean up another board, and then we'll do another one. Are you ready? Are you ready? Are you ready? 3, 2, 1, click. Hi, we're back. Am I in the frame? Am I not in the frame? Am I in the frame? I'm wearing a check shirt. Okay. All right, I'm back. We're back. We're back. It's you and me. We're in this together. Okay, now, what have I done here? Back to absolute values, okay? Absolute value graphs. We're starting slow. If you missed us from 8 seconds ago, we're starting slow. We're doing tables. It's old school tables. Domain and range, okay? But we're gonna start to analyze, all right? Because we wanna know how this moves. So, I have this now. I put something inside this. So let's do this the slow way, but we're gonna use our same values, okay? X, Y equals absolute value of x plus 2, and Y. Let's see this, I hope so. So I'm going to just pick whatever I want. Again, here I'm going to show +2, +2, +2, +2. I need to leave room, don't I? +2. So they're not ones, they're the numbers I'm going to choose to put in. Absolute value +2. Because then I'm going to need a little bit more space. We'll figure that out. So here are the numbers I'm going to pick. Once again, -5. -2, 0, 2, 5. And you ask, Ms. Thompson, can I pick any number? And I'll say, yes, you can. Absolutely. You can pick any number you want for x. You can put whatever you want to as long as it is in the domain, which in this case is all real numbers. Which if you don't remember about numbers, watch that video. But as we're going to find, if you don't pick the right ones, you're not going to see what you need. Right now, I'm kind of just picking the ones we need. But I will do an example later where we'll pick numbers that don't help us see it. Okay? But for now, we're going to pick what we know because I know where we're headed, right? When are we going to get there? Okay, so I'm putting -5 in for here. -5. I'm putting -2 in here. I'm putting 0. I'm putting 2. And I'm putting 5. Okay? Can you see me? Now you see me, now you know. So, can we see this table? I'm going to triple check. Let's zoom in a little bit more. Let's spin this around, yeah? Whoops. Zoom-a-doom-doom. This is seriously the most high-tech thing. -5 plus 2 is absolute value -3. Which absolute value of -3 is 3. -2 plus 2 is absolute value of 0, which is 0. 0 plus 2 is absolute value 2. Don't forget the absolute value comes after that addition. That's why these numbers are changing a lot more than the other one we did, which is 2. absolute value of 2 plus 2 is 4, which is 4. Absolute value of 7, which is 7. So I'm going to plot these micro points. Oh my goodness, I have to go all the way to 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm doing it tiny. We'll zoom in later. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Well, I don't think I go in the bottom half at all, do I? Let's plot my points. -5, 3. 1, 2, 3, 4, 5. Remember, I'm starting at the origin. Origin. Always. 1, 2, 3, 4, 5, and up 3. 1, 2, 3. -2, 0. Start the origin. 1, 2, and I don't move. Because I don't go up. 0, 2. Now I don't move from here, and I just take the elevator up 2. Oops, I put this at 3, didn't I? I'm going to fix that, because that is at 2. And it needs to be at 2. What did I do? Oh, no, sorry. I didn't trust myself. I hate when I do that. What is that doing? Is that right? I hate when I do that. 2 and 4. 5. 1, 2, 3, 4, 5. And 7, which take us all the way up to the top. Now, this looks weird because I don't see that reflection necessarily, but remember, it's all the infinite points. And what does it end up with? V? I have to trust that it's going to be a V. Where's the V? So where is my vertex in this one? And what are the coordinates of that vertex? Now let's analyze this -2 and 0 compared to this +2. Why is this negative, but that's positive? The reason why, have you come up with it? It's not because it's just the opposite. Because what happened right here, which is our vertex, what actually happened? By putting in the -2, we offset the 2 that was already there and gave ourselves the 0 that we ultimately want. Now, what happens when this is 0 is the y part of the vertex, of which we don't have on this one. We have an example later. We're going to see it all at work. Okay? How are we feeling on this one? Let's move on. We're going to spin. The next example. Well, what makes this different? This is actually exactly the same as the one we did over there. So I'm just going to graph it. I'm going to graph it knowing that I know the points. So the points were, I know this, the absolute value of x plus 2, and I use the points. Here's x, and there's y. I'm just recreating what we did over there. Okay, if you have to watch the other video, see it. We had picked -5, and -2, and 0, and 2, and 5, and I put it in here, and lo and behold, oh shoot, no, what we're doing right here. Lo and behold, I got 3, 0, 2, 4, 7, right? We're just recreating exactly this, sorry. I was thinking of the wrong thing, right? That is the exact same thing as that. So I'm just writing the numbers down, except for what is the one difference? The one difference, you ready for it? We're zooming in on it. Oh, we can't get any closer. Is that negative, right? Negative. So these are all the values of positive x plus 2. But when I make this negative, okay, and I'm going to skip these just because it's a time saver, all these become what? All these positive values, we can't have -0. All these positive values become negative. So what does that do for our graph? Well, in your tiny micrograph again. X, Y, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. I like making my dashes. 1, 2, 5, 6, 7. Alright, I'm gonna plot these. Ready? Negative 5. 1, 2, 3, 4, 5. 1, 2, 3. Do you think our vertex is in the same spot? We'll find out, I guess, right? Negative 1, 2, and 0. 0 and negative 2. 2 and negative 4. 5 and negative 7. Whoa! Whoops. Well, so hold on. This is still the origin, right? The origin's always there. And this is our vertex. And the vertex didn't change, did it? It was still 0, negative 2. And that's what it was in this other one, 0, negative 2. But what did change? The whole thing flipped over. All because of this negative. So the negative made it tumble over, and all those pretty positive absolute values became negative. Every single one of them. So let's compare these graphs side by side, shall we? As you can see, this one, vertex, negative 2, 0, and it goes up on either side, yeah? Over here, same vertex, negative 2, 0, but we flipped it over. And now it goes out there, and it goes over there. And what was the difference of the equations? Just the negative. See this one? Let's compare them together. Over here, we have y equals x plus 2. And over there, we have y equals negative absolute value of x plus 2. Two equations diverged in the yellow line. I'm sorry I could not travel both. Long rise to. Please tell me no at home. That negative has made all the difference. Alright, more later. Alright, I've got one example left. We're way in the corner. We've used up both boards. So, this is the same as our one over there. And I'm going to now use the powers of deduction to presume that my vertex is going to be at, it didn't move in the x, and down 3 in the y. Well, what does that do? So let's see, yeah? Let's use the exact same values. X, y equals 2x minus 3, absolute value, and y. So what are the things we chose? Negative 5, negative 2, 0, 2, 5. We'll have to have a micrograph like down here, and I'll zoom in later, okay? So, 2 absolute value of x minus 3. 2 absolute value 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 minus 3. That's what we're doing over and over and over and over again. We're just changing what we're going to put in, okay? What color dye do you print to your screen print? I don't know. Screen print, we've already got. Okay, so we'll stick with our color red for the numbers. So we've got negative 5, negative 2, 0, 2, 5. Well, this equals, this takes a little more doing. The absolute, this order of operation, okay, so we got to be clear on this. We do absolute values first, that's the innermost corridor. Absolute value of 5, negative 5 is 5. 5 times 2 is 10. 10 minus 3 is 7. This answer is 7. Absolute value of negative 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. Okay? I would write all this out, but there's just not room. Okay, so you gotta listen. Or compute it yourself. Absolute value of 0 is 0. 0 times 2 is 0. 0 minus 3 is negative 3. Wasn't that my vertex before? 2, absolute value of 2 is 2. 2 times 2 is 4. 4 times 3 is 1. I'm seeing a pattern, right? This turned into 5. This already is 5. 5 times 2 is 10. 10 minus 3 is 7. You see this reflection of nature? I took speech class. Here's our vertex. I see it. My guess was correct. But what happened to our graph? Is there room for it here? Let's hope. X, Y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I only did those because that's all I need to do. If you need to do more, do it. But you don't have to. Okay. Negative 5. Positive 7. Negative 2. Positive 1. Oh, yeah, this is minus 3. I didn't go down, did I? 1, 2, 3. I have to go down. 1, or excuse me, 2, 1. I'm getting slow on my graphs. And 5, 7. Yikes. Wait, hold on. It's a V. It's definitely a V. And it's definitely got its vertex where, there's a green, because everything's in green with vertex. Vertex is there, and it's point 0, negative 3. But I've gone, instead of going up 1 over 1, up 1 over 1, I've gone up 1, 2, 3, 4 over 2. Wait, up 4 over 2. That reminds me of what we used to call slope. That's like a 2 over 1. Is 2 over 1, is 2 and 1 a point? I think it is. Is that what that 2 means? Should I test my hypothesis and do it over and over and over and over and over again to find out? Yes. How's my hair? I need a haircut. I've already said that, haven't I? Let's look at all these. I'm going to take the little tour. So, this one we've got a 2. Let's look at our very first one. We're going to go over. Are you ready for a journey? Over to this board. Okay, hold on. We're at this board. You see it? There it is. There's the y. There's without the 2. Okay? Absolute value of x minus 3. Yeah? Vertex 0, negative 3. And it's going at a basically a 1 over 1, 1 over 1 over 1. Now let's go back here. It's just theme music for while we travel. Okay, now let's look over here. We again had absolute value, x minus 3, but it was doubled, right? That 2. And it's narrower. It's like pinched. It's like I want to take it and pinch it. I'm just going to let the cat out of the bag. It got steeper, narrower, because of the 2. If the 2 was less than 1, like between like 0 and 1, right? Absolute value. It would pull it apart. That's just what it does. It's the nature of itself. You can't, get mad at a leopard for its spots. You know what I mean? It just is what it is. Think on that until we're back next time talking about inequalities, linear inequalities. All right, ready? Seriously, how's my hair?